Welcome back. This is the second part of the notes for section 17.8, which is solving equations involving trig expressions. And if you can kind of keep in mind that these big ugly trig functions are just like a variable, like a or b or x or whatever, then this makes it very easy. And this is the reason why we did that quadratic review of factoring and the quadratic formula. So this says solve for the tangent of x, and you've got tangent squared of x plus tangent of x equals 56. This is just like if I had a squared plus a equals 56. The only thing is you got an ugly looking expression, but think of it as just a single variable. So what you're going to do first, I kind of think about it like x squared plus x equals 56. How would you solve for x? But instead I got tan x. So I'm going to subtract 56 from both sides, and I have a quadratic expression here. Just like if it was x squared plus x minus 56, I'm going to factor it because I know 7 times 8 is 56, and 8 minus 7 would give me 1. Alrighty. If I do the FOIL, tangent of x times tangent of x would give me tangent squared x. I'd have minus 7 tan x plus 8 tan x, which would give me 1 tan x in the middle, and then 8 times the negative 7 is negative 56. If you remember your steps for solving by factoring, you set each factor equal to 0, which is very, very easy. And you'd end up with tangent of x equals negative 8, tangent of x equals 7. Bada boom, bada bing. It's very easy, it just looks complicated. Now, if they'd ask me to solve for the angle x, I'd just do tangent inverse, but they didn't. They just want the tangent of x, so I'm done. So my answer is negative 8 and 7. Solve for secant of x. Again, think of this like a squared minus 3/4 and that. You got fractions here? Oh, you know fractions are our friends. Frickety fractions. I would get rid of those, so I would probably multiply through by 4. That's the least common denominator. 0 times 4 got real numbers to mess with. So 4 times secant squared of x is going to be 4 times the secant squared, and then 4 times 3/4. The 4's would cancel, and I'd be having 3 times secant of x. 4 times a half is going to give you negative 2. And now I'm going to see if I can factor it. So are there 2 factors of negative 8 that add to 3? Wait for it. Wait for it. I don't think so. So I'm going to have to use the quadratic formula because it doesn't factor. If it doesn't factor, quadratic formula. So remember, it's the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So secant of x, instead of just x, is going to be opposite of b is positive 3 plus or minus negative 3 quantity squared minus 4 times 4, which is my a, times a negative 2, which is my c, all divided by 2 times a. In this case, a is 4. Then all I do is simplify that out, and I get 3 plus or minus square root of 41 divided by 8. I cannot simplify that at all, so I am done. That's all I have to do. Alright, solve for the cotangent of x. Got to have it set equal to 0 first, so we're going to minus 12 from both sides. Then there's 2 factors of 12 that would give me 1, and that's 4 and 3. So I'm going to have cotangent plus 4, cotangent minus 3. Set each equal to 0. Bada boom, bada bing. They're very easy to solve. So cotangent of x equals negative 4, cotangent of x equals 3. Very easy. Now, when you're dealing with sine and cosine, remember that sine is between negative 1 and positive 1. And cosine is between negative 1 and positive 1. So for instance, on this problem, if I would have had sine of x equals negative 4 and sine of x equals 3, I'd have no solution because you cannot have sine bigger or smaller than the absolute value of 1. So in other words, it can't be sine x is never negative 4 and sine x would never be 3. So you have to throw certain answers out when you're dealing with sine and cosine. Tangent and cotangent can be anything. Likewise, if I go back to cosecant and secant, they cannot be between -1 and 1 because they're the reciprocals of sine and cosine, so you have to be careful there. Alrighty, I think that's it, and we will see you tomorrow.